Hello, my friends. I have a question for you. Have you ever wanted to shoot yourself out of a cannon and high five your best friend who is also being shot out of a cannon? Well, now you can, because we can solve that kind of physics with our knowledge. So, what do we got? We've got Steve. Steve's going to be shot at some angle, and that angle happens to be 40 degrees. And he's going to be shot at 45 meters per second. Now, meanwhile, 50 meters away, his buddy John is going to be shot straight up. But we don't know how fast to shoot him up. And that's what we're here to find out. So, the real crux of this problem is recognizing that these two are going to be shot out of their cannons and meet at some point. So the critical piece is that at some special time, which I'll call T flight, it's the flight time, I'll just call it T from here on out. At this time, John's position evaluated at that time equals Steve's position evaluated at that time. And this is true for both the for both the X and Y components. Right? Because in order for them to high five, they have to be at the same place at the same time. Same X coordinates, same Y coordinates at the same time. So let's just get to cracking. And all the question wants to know is how fast does he need to be shot? So you can do a little bit of a trick here. A lot of this information we actually don't need to know. So if I express ys evaluated at a time, then I will get the initial position, which is 0. And then, so this is for Steve. So then I'll get my velocity term, which is 45 times the sine of 40 times t minus gt squared over 2. I can do the same thing for John. Equals some velocity that I don't know, and he's being shot straight up, so I don't have to deal with any angles. So Vt minus gt squared over 2. Now what do you notice here? They look kind of similar, don't they? And thankfully, we can exploit that. If I do ys evaluated at a time equals yj evaluated at a time, I will get 45 sine of 40 t minus gt squared over 2 equals v big T minus gt squared over 2. These terms are going to cancel out. All I'm going to have left is these terms. I don't know the time, but that's okay, because time is multiplied on both sides. So v must be equal to 45 times the sine of 40, which in our case, 45 times the sine of 40 equals 28.9. And that's our answer. Now you might be thinking I got away with something here. Maybe I cheated or something. But nope, we're fine. And the reason is because I still have this undetermined time. So if I force my other condition, remember I have these two conditions. If I force my first condition, that will just determine what time do they meet. But the velocity, the y velocity, is totally determined by this equation. So if you want, There is a second check you could do. Force this to happen. Follow through with this equation, and you'll be able to find the time. And I think the time you'll get is 1.45 seconds. And then you can go back and you can check that these two conditions are met. That at 1.45 seconds, Steve and John are at the same X location, and they're also at the same Y location. Therefore, they'll have no trouble high-fiving. And that'll be our answer.